Thank you, Samir, for the introduction. I would like to welcome everybody from all around the world. For myself, I'm in the morning zone, kind of. I'm in Alberta, Canada. I would like to thank all the participants. I would like to thank Mohammed for taking time to join us for this webinar and share his experience. Mohammed is a lubrication specialist and reliability consultant with 25 years experience in oil and gas and refining petrochemical industry with maintenance, reliability and condition monitoring and oil analysis background. He worked in Middle East region. He has conducted numerous of lubrication training as BER ISO 18436 on all four levels, and has also resolved a numerous of lubrication related practical problem associated with rotating machinery. He also a member of steering committee of ISML, which is the International Council of Machinery Lubrication. Personally, I met Mohammed for about 10 years ago in one of these conferences, and we chat about reliability, and we found we have the passion about reliability and how we should prevent failure and not accepting failure anymore. I think Mohammed, he's going to share his story about a culture of not accepting the failure and how we prevent it. Before we gonna hand the mic to Mohammed and share his great presentation, we are waiting all for us. I would like to put some ground rule for this webinar. First of all, we have this already recorded and live stream, so anybody, one of your friends didn't make it, we advise you later, you're gonna send you a link, you can hand it to them. But also for during this presentation, everybody gonna be muted. If you have a question in the bottom, there is a QA section there. You can ask your question and we'll take it from there after Mohammed finishes the presentation. Also, once the presentation finish, you can raise your hand in the bottom there too, and we can unmute you and you ask your question directly to Mohammed. Mohammed, thank you, and you have the mic and you can share your presentation right now.
Yeah.
Samir, do we have any questions? I think before we move on, or later we have the question during the presentation.
So when do you want us to pose that, Mohammed? Should we pose that question now?
Which one? Those questions?
The poll question, the oil varnishing.
No, they should be in the end of the.
Okay.
Okay. So shall we start now?
Yeah, go ahead. You have the mic and you can share your desktop here.
Okay. So okay. So Bismillahirrahmanirrahim. Assalamu alaikum. And hello all the friends on this webinar on how to proactively deal with turbine oil varnishing. And thank you to Samir and Farooq for organizing this session. My name is Mohammed. Already Farooq has done, the introduction of myself. But just to give you a brief about my experience, I have been in Middle East for almost 20 years, and I have worked as a maintenance and reliability professional in oil and gas refining, petrochemicals and power industry. And specifically for the past 15 years, I have been the lubrication subject matter expert for more than 10,000 rotating machines across Shell PDO, experience with implementing practical measures for lubrication related failures, how to resolve them. All these is my past experience. And let's come to the subject. I'm also the certification committee member for the VDPR Varnish badge, which is the new body of knowledge which is getting developed by ICML. So industry rides on an oil film of about 10 microns. When we talk about industry, all sort of industries are having rotating machinery. And when we talk about 10 microns, all our rotating machines are having, majority of them are having lubrication, because lubricants are the lifeblood of our machinery. And especially for the journal bearings, the oil film thickness is about 10 microns, which is hundredth of a millimeter. So our limit of vision is 40 microns. So 10 microns we can't see with our naked eye. So this is what our industry is riding on. Oil varnishing problems across bulk lubricants, it's a it's a global problem across the industries, with various type of issues related to premature bearing failures, associated with journal bearings on turbo machinery in gas turbines and big compressors, uh, frequent choking of filter elements, uh, in addition to journal bearing deposition of varnish uh, the on the bearings, causing excessive temperature increase on the bearing, accelerated wear on the load gears, and also the heat exchanger poor performance because of oil deposition, varnish deposition on the lube oil cooler internals, causing insulation effect, and the oil will not get the heat transfer because of that varnish deposition on the coolers. It, some other problems associated with the oil varnishing. So, like valve sticking is one of the major problems. IGV, that guidelines was sticking problem in power generation industry, is the highest profile problem. Uh, in addition to the servo valve sticking problem, which is having a clearance of 3 microns. So you can think of a very fine 3 micron clearance when deposited with varnish. The valve is causing a sticking problem, which causes trips on the power turbines, and also restart problems associated with these turbines. Some more snapshots about varnish deposition. See this deposited varnish, once it is deposited on the bearing surface, it it creates a hot spot because the heat dissipation. One of the secondary function of lubricant is heat transfer from the bearing. But in case if the varnish is deposited, that location, the load zone, would not dissipate heat, and that's why that increased temperature would further escalate and cause further deposition of varnish and change the lubrication regime of the bearing. So this is a common problem across the industry. So lube oil varnish works similar to the cholesterol in the blood stream. So it's like the cholesterol in our machine. What causes the oil varnishing? What causes the oil varnishing? Basically, there are two phenomena causing varnishing. There are two phenomena which cause basically varnishing. The first one is the oxidation process, and the second one is thermal degradation. Oxidation is basically caused by four elements: the heat, air, water, and metal catalyst. So it is a fact that every 10 degrees Celsius increase in the oil temperature doubles the oxidation rate. And oxidation is a aging factor. It's a degradation mechanism which causes degradation byproducts, and every 10 degrees increase in the temperature of oil would cause the oxidation rate to double, which means the degradation rate of lubricant will be doubled with every 10 degrees Celsius. I have seen in companies which are running turbines with 50 degrees Celsius, their oil lasts longer as compared to the turbines which are operating at 70, 75 degrees Celsius. Because of the increased temperature, the oil life and the degradation rate is faster. So with the increase in the temperature and in presence of oxygen and which comes from the air and water, and in presence of metal catalysts, the lubricating molecules, they get react with the oxygen and form the oxidation degradation byproducts. The another phenomena which is caused, which causes varnishing, is thermal degradation. And basically, there are three different types of thermal degradation. One of it is micro dieseling. The subject is quite huge actually. Just to finish it within 30 minutes will be difficult because. But anyways, micro dieseling is actually the adiabatic compression of oil entrained air bubbles, because when the oil is having a lot of air bubbles, and these air bubbles, when they enter into a lube oil pump at a pressure zone, they get collapse and cause very high temperature at a very minute area. The temperature could exceed 1000 degrees Celsius and causes actually the burning of the oil, which causes this phenomena is called micro dieseling, and that's one of the phenomena of thermal degradation. Other way through which the thermal degradation occurs is through hot spots in the system, as I showed in the previous slide on bearing of the turbine, journal bearing of the turbine, with the showing this one showing hot spot, which causes the oil to become overheated, and at a high temperature the oil starts causing coke formation, and very hard deposits could occur eventually. And third one is filter induced electrostatic spark discharge. So spark discharge is one of the phenomena which is happening with very fine filtration in the inline filter elements. So the static charge which accumulates within oil is non-polar, but when it gets a static charge, these static charge, when it passes through the filter element and enters into the oil reservoir, there is a possibility of having a spark discharge, which causes very high temperature, and due to that phenomena, the excessive thermal degradation causes the oil varnishing to happen. Now, coming to the subject of definition of varnish, as per ASTM standard, ASTM D7843-18, varnish is a thin, hard, lustrous, oil insoluble deposit composed primarily of organic residue. Okay, so in this definition, the one important thing which they have mentioned is the varnish they have considered as an insoluble deposit. Okay, and secondly, which they have mentioned is it's a chemical change, and they have mentioned that it is an irreversible process. So and unavoidable. So oxidation is an unavoidable process, and this insoluble deposit formation, they have mentioned that it is an irreversible process. Now let's see the actual definition or a redefined, a definition of varnish. So varnish redefined. Varnish is actually oxidation degradation byproduct of mineral-based oils, which exist in the oil in two forms: soluble form and insoluble form. So instead of only one form, actually varnish exists in two forms, soluble and insoluble. But it depends on the temperature and the saturation level of oil. Let's move to the next slide to see how the soluble versus insoluble form of varnish. I will play a short 1-minute video to show how the soluble versus insoluble varnish effect. Let me tell you first about this video. These are the two oil samples. Actually, this is one oil sample taken from from a turbine, gas turbine application. And one of the sample, or this the particular sample, has been treated with the varnish removal technology, and this one has not been treated. This sample has not been treated. The one on the right side, uh, this is not treated, versus this one is treated. This one is treated and this one not. So what happens at a higher temperature of 50 degrees Celsius? Both of them will be looking like similar in terms of transparency. But let's see what happens when the temperature drops. Initially, the temperature is 50 degrees Celsius. We can see both these are almost similar. But let's see when the temperature drops. These thermometers are showing the temperature. Now 40 degrees Celsius. 35. See the sample on the right side, this sample, see this one as compared to this one. See, now at around 25 degrees Celsius, how much is it? Around, oh, just a moment. So see, at around 25 degrees Celsius at room temperature, you can see the transparency of this oil is still the same. This oil hasn't changed its state, but the oil on the right is showing a significant change in its appearance. So what does it mean? With respect to temperature, the varnish, which was in the form of a soluble form of varnish, it changed from soluble to insoluble with the drop in temperature. So the saturation level of varnish reduced with the temperature, and the varnish which was in the form of soluble its change in the state from soluble to insoluble caused this change in the appearance of the sample. Think about when this turbine shuts down, especially for the peaking turbines and the turbines which are, shut down and restart. At the time of restart, all the valves which get this insoluble deposited would fail to restart problems. So how to identify the varnish in the oil? Since 2014, since 2014, the varnish, before 2014, there were various tests which were performed. But since 2014, varnish potential test MPC became a standard test which in which the oil sample is heated for it took actually 5 days to accomplish this ASTM standard test. It's a 5 days procedure. The oil sample is taken and heated for 24 hours at a temperature of around 60 to 65 degrees Celsius. After that, the sample is kept in incubation at a room temperature condition at around 25 degrees Celsius for 72 hours. That means 3 days. So total 4 days. And then the patch is made at a 0.45 micron filter patch. And then it is monitored through a spectrocalorimeter. So the darker the patch, the higher the varnish potential would be. So generally, as a rule of thumb, it is considered that the values greater than 35 are critical. But in my experience, sometime within, like, even after 10, sometimes the machine starts showing varnish related problems. Even the varnish levels are just 10 to 15 range. So it doesn't matter. Actually, we have to monitor the trend of varnish increase. Another test which is important for monitoring the oxidation resistance of oil is to monitor the antioxidant level. The ruler test, which is remaining useful life evaluation routine. And this particular test actually measures the two antioxidant additives which are added in turbine oils, amines and phenols, their strength in used oil as compared to fresh new oil. So it's a reference test with how much percentage of amines and phenols are remaining within the oil as compared to the fresh oil level as a reference. So antioxidants are the first line of defense for a turbine oil. So once the amines and phenols they get below 20%, then the oil is prone to have very high oxidation. These antioxidants, they keep the oxidation level to a minimum. That's why they are very important to be monitored. A lot of companies, they are even not having this particular test done included in their oil analysis program. These are the two important tests that need to be part of. There are several other tests also. So now coming to the oil filtration technologies, how we can fix or remove the varnish from our turbine oils. See, the conventional method of mechanical filtration can only remove the particles which are insoluble. So all the conventional methods like centrifuging, mechanical filtration, absolute or nominal filtration, even electrostatic filtration, and some sort of like agglomeration and depth media filtration. All these can only remove insolubles. They need actually particles to remove from oil. But what about the soluble content of varnish, which we were talking about? We have seen the varnish changes its state from soluble to insoluble. When majority of varnish during operating condition of a turbine is in the soluble form, how can we remove that varnish from our oil, which is in operation? So for that, the the technology which is active, which is very successful for removal of soluble contaminants is the ion exchange resin technology. So ion exchange is the only technology which removes both the soluble content of varnish and also the insoluble varnish. I will tell you how it removes the insoluble varnish in the next few slides. When I am talking about insoluble varnish here, it means the insoluble varnish which has been deposited within the system. Okay. So there are various varnish removal strategies which are currently being engaged across various companies globally. One is PAG additive. Some companies, they claim that they have PAG additive which can resolve and make the oil almost varnish free oil. Basically, the way PAG additive works is it's having it increases the solubility of the existing oil, and when it is added in a 10% by volume in the existing highly varnished oil, that actually complicates the oil chemistry, and it would form its own and later it would form its own varnish, and this would create a new brand of oil actually. So PAG additives and also the oil supplier, there will be no support available from the existing oil supplier, uh, which is whose oil is in the machine. Like 90% of oil is the from a certain oil supplier, and if it is getting mixed with an additive, aftermarket additive, um, how are they going to figure it out? What is the oil chemistry then? This is one of the remote strategy which is getting employed, but it is having its own challenges. It may work in removing certain form of varnish. It may keep majority of varnish in the soluble form, but it will later might create complications and problems. Another way is high efficiency filtration. We already talk about high efficiency filtration like depth media, balanced charge agglomeration, electrostatic cleaning. But the problem with these technologies, which are high efficiency filtration methods, mechanical methods, they can only remove insoluble particles. They cannot remove the soluble content of varnish, which is actually the culprit. And now coming to the gold standard, which is the ion exchange resin. Ion exchange resin has been proven to remove both the soluble and insoluble content of varnish. How does it work? It works on the basis uh, of adsorption principle, and it actually removes the soluble content of varnish molecules at a molecular level, and these particles get adsorbed, coated on the ion exchange resin surface, and that's how it prevents the oil from getting saturated thereby preventing the varnish under all the different operating conditions. How does the varnish formation cycle work? Initially, the varnish starts with the oxidation process. So oxidation is the unavoidable process. Uh, it is going to happen anyway. So antioxidants can only reduce the oxidation process, but it cannot 100% avoid happening oxidation. So oxidation is the first step which happens. Then initially the varnish is in the form of soluble. So solubility is the first phase, first stage of varnish formation cycle. So gradually the level of varnish increases within the oil as the oil gets older. And if there is no mitigation, when it will reach to a saturation level, that varnish will start getting precipitated out of oil, and that will be the second stage of precipitation. Once it starts precipitation, then these precipitated particles, they start agglomeration and combine. These small particles which are initially precipitated, they will start combining to form a larger agglomerated particles, and these agglomerated particles, they start getting deposited within the system, and this is the fourth stage. Now interestingly, this is a unavoidable process. This is a irreversible process. Oxidation is an irreversible process, but the stage 2, 3, and 4, they are reversible. Step 2, 3, and 4 are reversible processes. So if you have engaged a varnish removal system which is removing varnish at a soluble form, so it will bring the varnish levels to lower than saturation level, and the particles will start getting, this cycle will start moving in the opposite direction. So the deposited, what will happen, the precipitation will form soluble, will change into soluble form. The agglomerated particles will come to the precipitation form, and the deposited varnish within the system will start getting redissolved back into the system, into the oil, and then get removed from the soluble phase. That's how the deposited varnish from the system will get cleaned. So as the oil gets cleaner, it will clean the system. So now coming to the how early we are detecting this varnish related problem within our machines. As we know, most of us might be knowing this PF curve, where on y-axis we have condition and on x-axis time. So initially the condition of the machine would be nice and it will be operating. There will be a point where failure would start to occur, and there will be a point where a potential failure condition will be there to identify that failing condition. So, and then if no action is taken, the functional failure will happen eventually at a later stage. This is the PF curve, and the beauty of having proper condition monitoring program is to actually detect the problems early as possible. This is the purpose of condition monitoring. So how early we are detecting the problem depends on the oil analysis program, especially in terms of oil varnishing. The earlier we identify the problem, the better it is. In fact, at a very early stage, we can take a mitigation action in order to extend the life of our lubricant, improve the reliability of our machine, and ensure trouble-free operation. So now coming to some of the proactive actions associated with oil varnishing. So first thing is we should have a proper oil analysis test package. A lot of time when people they approach me and ask about the oil analysis, to review their oil analysis report for their turbine oils, I see a lot of malpractices. A lot of the reports are not having the right analysis package. Same test package they would have been using for other machines. What they are using for turbine oils. For turbine oils, there are some specific tests that need to be used. So selection of the right oil analysis test package is the first step. Baseline oil assessment, especially for the new machines, it is very, very important to have baseline assessment. Not like, especially when we see new machines, we have spent, millions and millions of dollars, and we are doing baseline assessment for vibration, for performance, but unfortunately for oil, rarely, very few companies, they do a thorough baseline assessment of their oil at a early stage. Oil analysis at a correct frequency, that's also very important. As per, as per the standards, it is recommended to do high-speed machinery oil analysis at a frequency of 500 hours. But unfortunately, rarely anybody, 500 hours is approximately equal to 20 days, but not some companies, they are doing oil analysis on yearly basis, some of them on 6 monthly or quarterly. Majority of the companies, they are using doing oil analysis on 3 monthly basis. So in between, if there happens something wrong, so it will not be, you will not be able to detect the problems early. So that's why correct frequency is very important. And we must do oil analysis through a reputed quality lab. Just recently, I had a case where a customer, they told that they need an MPC test to be done. They informed their oil analysis lab to get the results as quick as possible, and the lab responded within 24 hours. How come? Because as per the ASTM standard, the MPC test takes 5 days. So many labs, they might not be using the actual ASTM or standard. They might not be following the standards, and there might be bypassing the steps, key steps, just in order to get the results quicker. And it is also important to have correct interpretation. But in order to get correct interpretation from the oil analysis reports, the one important thing is the decision makers must be trained on how to interpret the turbine oil analysis report. A lot of decision makers, they are not aware of how to do the interpretation part. This is very, very important. And monitoring the trends instead of absolute values. So trend monitoring is very important. Instead of just seeing a single value, it is important to see the trend, historical trend of the oil analysis report parameters, and monitor and maintain the antioxidant levels. Antioxidants are the first line of defense for turbine oils against oxidation. So monitoring antioxidant levels and maintaining their health is the key. Minimize the chances of a spark discharge in lubrication system. Every turbine operator must identify there are some methods to identify the spark discharge phenomena if it is happening within their lubrication system. And if it is happening, there are ways of minimizing that phenomena, because this is also one of the key degradation, especially in gas turbines and steam turbines. Engage correct mitigation technology. So this is again very important to engage the correct technology that is capable of removing both soluble and insoluble contaminants from the oil. Not only just insoluble, but soluble is the culprit. So the technology must address both. And last but not least is the online monitoring of oil varnishing. Earlier this year in January, I implemented an online monitoring system for monitoring the live real-time, varnish trending of the oil, how the oil varnish was getting removed and the trend of oil varnish levels were reducing. That's what the online monitoring part, which I implemented. And that was one of the things which I think in future companies should do, online monitoring of oil varnishing. Samir, Samir, if you
Yeah,
are there, can you just take that poll?
sure. I'm putting forward the first one.
Okay.
So the
So
question, I think, if you see it, guys, talk about, did you face any of the oil varnish problem in your company? Yes or no? So I'll give it another 10 seconds, 15 seconds to see get who has this problem. So another 3 seconds. Okay, Samir, do we have a result there?
Yeah. You can see the result.
Not yet. Okay, I can see here. So I think, Mohammed, they have a big number of audience you have there have the problem. So this is not surprise, I think. Not
yep,
surprise to you.
yeah, I know that.
Okay,
Okay,
that's good.
So
So there is a big problem we need to solve for these guys.
sure.
Okay, you have another question?
yeah.
Okay, the question about, are you satisfied with your oil health management program at your facility? Yes or no? What you guess, Mohammed? I think you've done this question many times, so I think you have there is a consistency among all the professional and the business that they are having the same struggle, I think.
Yeah. That let's see the answers first.
Okay.
You don't want him to influence the answers. Okay, let me share the results.
Yeah, which is expected. 87% they say they have a problem. 90% I think they say we are not doing much to resolve it.
Enormous. Say 91% are not satisfied with their current oil health management program. So, guys, there is an enormous opportunity in terms of, it's not just varnish, it's actually directly addressing the business performance of your companies. Because these big machines, critical machines, which are having bulk lubricants, they are actually the heart of the machines, the heart of your facilities, your plants. With the downtime associated, there will be enormous losses associated with production and maintenance.
Okay, do you have any other question or?
Yeah, we have one more.
So are you currently having any oil varnish removal system engaged at your facility? So do we have any results?
Yes.
Okay, I expect this too. So it's
Okay,
like a 50-50.
yeah. So at least it means that almost like 45% do have some sort of a varnish treatment system um, in their facility, and almost 55 they don't have even. So let's start having discussion on how to deal with this problem within your companies, uh, and hope to see you. So let's move on the next slide. This I want to share the last slide. Okay, so this is one of the case back from 2017 of how the oil health from a very high varnish system, which was here, see 50, MPC was here 50 in July 2017 with a high acid number, and the particle count was also abnormal. So after having the oil treatment by ion exchange resin, the acid number dropped and returned back to healthy state. The particle count reduced to and it was back to healthy state, and also the varnish trend from a critical level returned back down to a healthy spec oil. The oil almost became, from a very dirty state, the oil became just like new. So as good as new. So this oil could last for many more years. Instead of a lot of companies, what I have seen, once the oil is at a very highly varnished state, they go for oil replacement in a hope to resolve the varnish problem, but actually it doesn't. So just by oil change is not the solution to the problem. It's a very expensive option, but still it is not a solution. Last time they replaced the oil in 6 years, next time they replace the oil in 4 to 5 years, and so on. The time, because the deposited varnish within the system would remain there and would eventually cause more varnish to happen. So questions, you can now open the questions, Samir.
Yeah, sure. One first question is from Rizwan Ahmed Malik. Varnish is a problem when it becomes insoluble. Once insoluble, will it not be filtered by media filters?
So, Rizwan, you are saying that varnish become insoluble, will it not be filtered with the media filters? First thing, you have mentioned the varnish when it changes the state from soluble to insoluble, it will already be in a highly saturated state, and once it changes the state, it will not remain in a precipitation or agglomeration form and suspended in the system. It will immediately start getting deposited within the system. So the deposited varnish, as we have seen here, it will eventually cause deposition on your critical systems and start creating problems. So unfortunately, that insoluble varnish will not be in an insoluble state at operating temperature. Majority of varnish at operating temperature would be in the soluble form. Okay.
Okay. Anybody has any question, you can raise your hand so we can unmute you for your questions. Do we have any questions here? Okay, meanwhile, if somebody think about question, I think there's
one question here.
Yeah.
Best varnish removal unit in the market now, from your opinion? From Mohammed Al Jamal.
at this stage, I think there are several, there is not a single company. There are several companies which are having, ion exchange resin based, solutions, skids. There are various manufacturers available in the market. It depends on, you know, uh, because at this presentation we will not be saying that this company is good and that is good. We have to take the case and work over it in a separate, that's out of the scope. But there are several. Ion exchange resin is the solution to your varnish problem. There are several suppliers available in the market, and we have to identify whose solution is the best for your application.
And I think that my advice for our audience here, if you have a specific question which is may require some commercial type of answer, that's why Mohammed, you avoid this. We can show you later, maybe Samir will show you where you can ask Mohammed directly and get a direct answer from him. We have another question coming to here is about best, okay, it's the same thing. Okay, I have a question. In my opinion, the way we are treating the varnish problem by accepting the varnish as a fact, and we have to live with it, and we need to treat it after it happens. So we know that it happened because of oxidization or because of the thermal issue, and this is the root cause. If right now we are treating not the root cause, we are treating the symptoms, which is the moment the varnish in the system, how we can remove it quickly before it causes damage. So from your experience, what we can do working on the root cause before even accepting the varnish is part of the system, now we have to think about how to take it away. This is a little bit...
Farooq, you have asked a very, very, very good question. This is what the proactive thinking is. The first thing first is, let me give you an example. Just recently, one of the company approached me, and they shared their oil analysis reports. When I reviewed their reports, I found that they were using the oil which has almost been obsolete across majority of countries, which was group 1 based oil. So there are various groups of group-based oils, used in the market. The group 1 is the oil which is having highest tendency to oxidize. It's having very high oxidation rate as compared to group 2 and group 3. So there are companies. So first thing first is you have to select the right oil, which is less prone to oxidation. And you have to do the baseline assessment and start monitoring the trends. And if you could have keep your antioxidant levels at a very high level, your oil may last for more than 25 years without any problems. The same oil can be used for more than the life of the machine. So there are ways of achieving that through proper holistic approach. It's not like just installation of a varnish removal skid. There is a whole set of steps which need to be taken, which include monitoring, should have proper oil management program, oil analysis, proper tests. There's a whole lot of things to prevent varnish happening within the system in the first place.
Okay, so this is, I think, the advice for everybody. Don't accept the fact that the varnish is something you should avoid. You have to take all the proactive action before even thinking about this removal unit. So I have 3 questions here. I would like really encourage my audience here to take the mic. Mr. Malik, Razwan Malik, do you want to take the mic and ask your question directly to Mohammed? Malik, do you want to take the mic? If you want to unmute Samir Malik, he can ask the question directly. Yeah, Razwan.
Yeah, Assalamu alaikum.
Walaikum salam.
Salam.
Yes, Mr.
Yeah,
Rizwan.
just I have a couple of questions. I mean, what parameters we need to look for? I mean, once we make a contract with the lab to cater for the turbine oil. And the
Yeah,
secondary question is,
you,
I mean,
okay.
if we use synthetic oil, do they fare better than the base mineral-based oil?
Okay. So the answer to your first question is, the first thing is you are talking about steam turbine application or a gas turbine application,
Basically, steam turbine.
and the volume is around, because see, the way I answer, I can give you specific, few parameters to be included in the report, but when I try to give an answer, I used to first identify, are you specific with certain application? For steam turbine, as an example, now you have just mentioned, in addition to the MPC varnish potential test, total acid number, ruler, uh, ISO particle count, spectrometric analysis, you should also have a demulsibility test, which is very important for steam turbines, okay, application, because demulsibility is the water separation property of oil. And in steam turbines, there is an inherent problem in majority of steam turbines to have water ingression due to condensation of steam within the lubrication system. That's why these are some of the tests which are very important uh, for the turbine oil analysis contract. But if you have any specific case, let's talk it out, later. And
Yeah,
what
fine.
was your second question?
The second question is, if we use a synthetic oil.
Yeah. So regarding synthetic oil, definitely synthetic oils are better in oxidation resistance, and they are having more improved performance characteristics. But the cost of synthetic lubricant is maybe 4 to 5 times more expensive than your mineral-based oils. So in that case, if you are spending 5 times more expensive oil in your machine, you should expect 5 times more life from that oil. But it doesn't happen.
Mm,
By
yeah,
maintaining your mineral-based oils in a healthy state, if you can achieve 20 years without problems, why should you have to go for a synthetic lubricant for your turbine oil application?
yeah.
So
One more,
synthetic
another point
lubricant is a
was,
very, yeah, okay.
yeah, another point was, I mean, this frequency of analysis, I mean, sampling,
Yeah.
and from where you take the sample. Normally, we take from the return line or from the sump. Are they the best point to be taken?
See, for each of the location, there is some specific reason. Like for return line sampling, actually, the purpose of taking the sample from the return line is to identify if there is any excessive wear happening within the bearings, to identify any wear metal content. If you take the oil sample from the tank, most of the people, they directly take it from the drain of the tank, which is not the right location, because a lot of chances of having contamination and sludge settle down in the bottom. So ideally, you should take, for as a general rule, in a circulation system like a turbine application, it is advisable to take from the discharge side of the pump before the filter, because
Yeah,
the main reason is to have a representative sample, which is representing the bulk of your lubricant within the system. So if you are taking a sample from a location which is representative of your bulk oil, that is the right location. And because the pump is taking the suction, and then this oil is actually, before entering the filter elements, it means this is the oil which is coming directly from your bulk reservoir, and that's what you want to find out, how is its health is. Okay.
yeah.
I
Thank
have a
you.
Okay.
question for
So
Mr. Muhammad Khan. Muhammad Khan, you would like to answer your question? I mean,
yeah, Mohammed
ask your question
Abbas
directly
Khan.
to Muhammad Khan. Yeah. Muhammad Khan,
Yes,
are you ready
I
to
am.
ask
I am.
question?
I am reading his question.
Okay.
Is it possible to put this varnish machine in line with lubricant tank? like other centrifuges? Yes. This majority of varnish removal systems are engaged as a kidney loop filtration, offline filtration system while the machine is in operation, while the machine is running. So usually the oil from the reservoir is taken through the drain of the reservoir as an inlet to your varnish removal machine. And after cleaning, the oil is returned back to the same tank from the top of the tank at a opposite side in order to create a sweeping effect. And that's how the oil is in circulation through the varnish removal skid, just like a centrifuge. So, and as the oil gets cleaner within the bulk oil reservoir, the same oil is traveling throughout the system, and and the clean oil will clean the system.
I think the last question here, we're gonna take it. Then we're gonna talk about what's coming for from your side on the Notify Academy and how we can get your help using Notify application.
There's
using
one.
Notify application. Huh?
There's one question in the chat by Abhilash. RPVOT test or FTIR test, which method is better suitable?
In my humble opinion, RPVOT, actually I have written an article on RPVOT test, and it is on my LinkedIn profile, and that same article has been taken by Machinery Lubrication magazine, and it is published there also. So anyways, RPVOT is basically an oxidation test, rotating pressure vessel oxidation test, but it is having issues. It is a very sensitive test. It is an indirect method of measuring oxidation level, and there is a repeatability issue. If you, what in my experience, I have seen the same sample sent to two different labs, the results we get entirely different. It's a very, very sensitive test, RPVOT. And that's why instead of going for an indirect test like RPVOT, or it is advisable to have ruler test, remaining useful life evaluation routine test is preferable as compared to RPVOT, because ruler is the direct measurement of oxidation resistance, because it is measuring the antioxidant level, and it is repeatable, it is more accurate. So in my opinion, instead of RPVOT, ruler test is the most preferable test. Okay.
To a point where we'd like to share with you two things. One related to what is coming from Mohammed in terms of in the Notify Academy as courses. We're going to talk about this. But before we go to the last item, I would like to show you where you can reach Mohammed if you need to ask very specific question. And this is something you go to the application, which is Notify. You download it in your app, in your phone. And maybe Samir, if you would like to share your desktop and show them where they can get a knowledge. Generally, you can go and select the industry, then your topic, which is maintenance reliability, oil and gas, maybe here. Okay. Then you click maintenance reliability. Then when you say submit, technically, you're going to get everything related to maintenance reliability in one place. Related to a feed, so articles, video, you're gonna see it on a daily basis coming, addressing these two area. Also, if you would like to ask questions, and Mohammed, he will be maybe from time to time publishing an article here. If you have a specific question, a general question around anything related to maintenance reliability, you click there, you ask the question, and this question will be directed to about 90 subject matter or 100 subject matter experts we have in Notify. Now, if you would like to ask specifically to Mohammed is a lubrication specialist. So if you go to machinery lubrication, you can find Mohammed there. You click on him and you can schedule a call or communicate with him directly. So this way you ask him very specific question about which filter brand he could recommend because he have the experience, but on a public space, he is not really, as a professional, he's not here to promote any specific brand. So if you are here to ask him very specific question, which kind of analysis, what kind of brand you would like to use, he's there to help you. So you can ask him. Also, if you're looking for some solutions as a company who are maybe selling some product, we are still importing more and more of these companies. I don't know if we have a lubrication company here yet, but in future you can see some lubrication brands who are selling filter examples. You can find them here. But definitely for expert, you have Mohammed and you have other, but Mohammed is here, so you can ask him anytime using the, what you call it, Notify application. It's very easy, very simple. It's free of charge for you as a guys, as a business professional. You don't have to pay anything, okay? And these, all the business professional or all these subject matter expert we have, they are here to help you to get better and better on how to prevent failure. I think this is it. The last item to the right, you're gonna look at the Academy on the same app. That's where you can register for any future webinar or courses. Now, this is a place where I can ask Mohammed what's his plan for offering courses in Notify Academy. What do you think?
Yeah, there are some, actually, this was from a higher level. So, but in future, my plan is to go with some specific, subjects or topics within machinery lubrication. And there are numerous areas where we can provide short courses of maybe few hours, sessions, workshops. So that will be published in future on the Notified.
Okay, so stay tuned. You will be notified on new courses coming from Mohammed. Usually our courses is 4 hours per day. It usually run at a very affordable price. We try to make it affordable for everybody can join us. So please wait for our notification around the courses on lubrication offered by Mohammed and Notify Academy. I'm not sure if we have any last question here before we close the session. Have you any measurement reference to MPC 15 200 liter capacity? How much time it required to remove varnish to acceptable level? So you're talking about some sort of way to understand how long it takes to remove varnish on 200 liter a kind of reservoir with MPC 15. I'm not sure if this is an oil type or what.
There are many questions. First, we have to know about the system, how old the oil is, what are the other parameters like total acid number, particle count, and there are many things we need to figure out.
Since we are running out of time, and I will recommend this, tell these guys they can reach you on Notify anytime you can ask the question, ask session, or you go click on Mohammed page, you can direct your question to him, and he's ready to help anytime. And at the end of this session, I would like really to welcome everybody and thank you for attending this, which is scheduled to be almost for half an hour, but because it's too much information, a lot of interest there, we are almost an hour and a half now. So I would like really to thank you, Mohammed, for taking time and effort to join us for this webinar. Also thank all the participants. As I said, you can still reach this material on the YouTube channel for Notify. So you can forward this to your colleagues who didn't make it. Also, we're gonna send you an email with some questionnaire. If you can give us your feedback, how we are doing and how we done for this session. There is always area of improvement. We are not perfect. I think Mohammed is agreed that continuous improvement better than postponed perfection. And we always looking for way to improve. So any feedback we got related to this session, we are welcome to see it and appreciate your time. Samir, if you have any last call or a last comment, then we give Mohammed the last comment, then we close the session.
Thank you so much, everybody, and for joining in and giving us the opportunity. So uh, we are hopeful that you have learned and something and which you can go ahead and apply to your work. And thank you so much, Mohammed, for taking time out and giving us the opportunity and educating them. So yeah, Mohammed is on notified. So please come on notified, ask him questions, and he is there to help you. So
Yeah.
let's build a community of maintenance and reliability professionals because you guys are doing a great job, and the devil lies in the detail. So let's fix that.
So Mohammed, you have a last call there?
Thank you everybody for giving me this opportunity on this platform. I hope this is going to be one of the very big, platform across the professionals, which will be used by millions, hopefully within the coming years. So thank you, Farooq and Samir, for organizing this session. Thanks.
Thank you for everybody. At this point, we're gonna close the session. Thank you and have a good day, and see you in the future for any upcoming training or webinar. Take care. Have a good day.
Everybody, take care.
Bye. Bye.
Bye.